Here, we can see the animation of ground beam and how it is being constructed. Starting with the steel bar. In this animation shows the steel bar being arranged properly from the bottom. The bottom will have 2 long steel bar and 2 short steel bar with the same diameter of steel are used. Next, at the end of each side of ground beam will having the use of a C shape of steel bar, which is also same size as the steel bar used at the bottom of ground beam. After that, another 2 more steel bar will be added toward the top ground beam. The diameter of the steel bar is smaller than the previous. The steel bar will actually arranged same as it described in the drawing plan. Now continued with added girth around the steel bar. The girths are placed in a specific length from center to center. Now we can clearly see how the girth being arranged.
Now, here we'll have a more precise example photo given as a sample for the arrangement of steel bar inside a ground beam. This is mainly shows how a ground beam look like. And at the end of the ground beam is the column stump. Now, let us look at the video that mainly shows how the process of constructing a ground beam. First, the construction start with excavation. Next, will be the constructive formwork. The formwork be constructed by using sawn formwork at the side of ground beam. Then, the arrangement of steel bar, girth and strips will be placed nicely into the formwork. Finally, pour the ready-mix concrete into the formwork and let it dry. This video shows a simple construction of ground beam. Before we start the quantity measurement for ground beam, let us take a look at the ground floor key plan. The plan that we choose for this project is the plan for an office building construction. From the ground floor key plan, we can clearly see the size and the dimension of ground floor. Now, we zoom in to see more clearly about the dimension from AP to AP1. It's stated that the length is 5,000 mm. Inside the plan, we can see that the ground beam type 1, which are stated as GB1, is located at the first row and the last row of the plan. For ground beam type 2, which stated as GB2, are located at the second until the fourth row of the plan. Where for the ground beam type 3, which stated as GB3, is located at the side of the plan where the beam is in vertical position. And here will be the detailed plan for ground beam. This is mainly show us the side view of ground beam, where the plan will state more precisely about the ground beam dimension. First, we must write the title of the quantity measurement, so that we can know that the main topics of the quantity measurement is about ground beam. Next, make sure there is a taking off list below the title. The ground beam taking off list include site clearance, excavation, reinforced concrete, concrete blinding, reinforcement bar, stirrups, and also formwork. Must not forget to write down the unit for each of the item in the taking off list. Next, form a query list. It is a list which used to list up items that are not stated in the drawing plan. Now, let us start to calculate the site clearance. First, always remember to write down the title. Next, below the title we must write the description of the subtopic that we are about to calculate. Then, look forward to the ground floor key plan in order to view the size of the site clearance to find the total area of the site clearance. At here, we should get the total length and then multiply with the total width to get the total area. Total area we get from the calculation will be 1,249 meters square. Next subtopic will be the excavate trench for ground beam. For the first stage of excavation, according to the standard, the excavation trench of ground beam must not exceeding 0.25 meter deep, commencing from reduced level. Now we will start calculate from ground beam 1. Ground beam 1 is stated in the ground floor plan. The length is equal to 5,000 mm less with 2 times of the half of column stump. How can we know the size of column stump? The size of column will be stated at the column detail plan. There will be a table of column. From the table we obtained all the size of column, where the size of it are 400 mm length and 400 mm width. To calculate the length of ground beam excavation, we must always remember to look back to the ground beam detail plan. At here we must less 2 of a half of column stump to get the total length. From the detail plane of ground beam 1, we know that the depth of the ground beam excavation is 600 mm. Must not forget about the 50 mm of blinding. So, the total depth of the ground beam excavation will be 650 mm depth. Since the requirement for a first stage of ground beam excavation is not exceeding 250 mm deep, so we only can take the deep as 250 mm. At the first column of the form, we will state out how many pieces of ground beam which have the same dimension and time with the excavation dimension of the ground beam, which is include the length, depth, and width of the excavation trench of ground beam. Remember, the amount to be inserted to the second and third column is in meter, and the total of the calculation will be written at the third column. If the dimension of ground beam are having the same dimension, you can write at the description column inside the form. Must not forget, when continue the same subtopic at the next page, make sure that at the top of the page, the description of the subtopic are written. The calculation step will be as before described. The total we get from the calculation is 0.63 meter. Then, move on and continue the first stage of excavation. The calculation will be same as before described. The total after the calculation will be 16.1 meter. After finish all the calculation for first stage excavation. Sum up all the amount and get the grand total of the first stage excavation. South now, the grand total we get for the first stage excavation is 37.43 meter. Finally, write the grand total of the first stage excavation at the beginning of the page that we start the calculation of first stage excavation. The grand total of first stage excavation is written in a round figure of 37 only. Of ground beam excavation, it will be continue with the second stage, where the excavation deep are exceeding 0.25 m but not exceeding 1.00 m. We know at the total depth of ground beam trench excavation needed is 650 mm deep, as the first stage already have excavate for not exceeding 0.25 m, which mean the first stage only can excavate maximum 250 mm. So, the second stage of excavation will be the continuation for the first stage of excavation, where, as required for second stage is excavation trench, exceeding 2.5 m and not exceeding 1 m. For the continuation of the first stage excavation, the leftover depth for second stage of excavation is only 400 mm. Now, continue the calculation for the second stage excavation. The step of calculation is as before described. Now, let us move to the next topic of ground beam quantity measurement. It is about the reinforced concrete. The detail of the reinforced concrete will be as described in the query list. It states that the ratio used is 1.2.4 with 20 mm size aggregate. To start the calculation, let us look back to the ground floor detail plan to see the size of the ground beam and to ensure the reinforced concrete that needed to be used. Now look at the calculation for reinforced concrete. The calculation, we need to find the length, width, and also the depth of ground beam. Then get the number of ground beam, multiply with the length, width, and depth of the ground beam. So we will get the total for the calculation. Do you know how to get the number which being inserted to the first column? Come and let me show you. Look back to the ground floor key plan. The plan shows that the whole building have 2 row of ground beam 1 and 3 row of ground beam 2. Each row have 12 piece of same size ground beam. South, this is how the number of the first column is being inserted. After that, continue calculation for reinforced concrete as before described. The next subtopic is about the concrete blinding for ground beam. For the concrete blinding, the description is 50 mm concrete blinding laid under ground beam. The calculation is include the number of ground beam multiply with the length and then multiply with the width only, so we can get the total of concrete blinding. Then, continue the calculation for concrete blinding. Use the step as before described. After that we will move to the following subtopic, which is the calculation of reinforcement bar. Before that, let us look back again. You can see inside the ground beam detail plan shows that the size of reinforcement bar used, and also the quantity of reinforcement in each section. Now, for the reinforcement bar subtopic, we transfer the detail drawing for the section of steel bar into the form of quantity measurement so we can clearly know which section of which type of the ground beam are we calculating. In the steel bar quantity measurement and ground beam, we have categorized the calculation based on the size of steel bar. First, we will calculate for the 16 mm diameter steel bar. Now we can see that inside the drawing shows the total length of the 16 mm steel bar has to be calculated as 5000 mm less with the length without the bar, as the steel bar length is until the half of the length of column stump. So, we have to add column stump length by 1/2 of column stump length. Must not forget that in the plan also shows that there is a bend at the end. So, we have to add bend by 5d, where the d is the diameter of the steel bar. Now, we will have the total length of one piece of 16 mm diameter steel bar at end of the left side of ground beam 1. Now, we have to calculate how many bar which have the same size and also same length, so that we get the total of these bar at the third column of the quantity measurement form. Make sure that the amount is already converted to meter before put into the left side of the column. Then, let us move on to continue the calculation for the 16 mm diameter steel bar, until we get the grand total meter of all 16 mm diameter steel bar used in this project. So, now we can proceed to refer on the British standard, BS 4449, to get the mass per meter of the 16 mm diameter steel bar. So, here we can get the figure of 1.579 kilograms per m and multiply with the grand total length of steel bar. in order to obtain the total mass of the 16 mm steel bar used in this project. Now, the total mass we obtained is 1,123 kg. After that, let us move on to the calculation of the 20 mm diameter of steel bar used in this project. Use the same step of calculation as in the calculation of the 16 mm diameter steel bar. Lastly, same as the step in the previous calculation for the 16 mm diameter steel bar, we need to get the grand total of the meter of steel bar used. Refer to BS 4449, Table 2, and to calculate the total mass of 20 mm diameter steel bar used. Then, move on to the calculation for the 25 mm steel bar used in ground beam. Use the same step of calculation as in the calculation of the 16 mm diameter steel bar used in this project. Refer to BS 4449, Table 2. Calculate the total mass of the 25 mm diameter steel bar used in ground beam. Now, we continue the next subtopic, the 10 mm diameter mild steel bar used as strips. To calculate the length used for the 10 mm mild steel bar used as strips, we look forward to the ground beam detail plan. At the ground beam detail plan, we can clearly see the length of the strips. First, we calculate the bill of length. We obtain the length from the ground beam detail plan of 5,000 mm, and less with the amount of 2 multiply with the half of the column stump. Then, we will have the total length of it. To calculate the bill of bar, use the formula of length divide with the spacing of 225 mm center to center, and add 1. So, now, we will have the total bill of bar. The amount of bar we have here is 21 nos. So, now, we continue the calculation for girth width. To calculate the girth width, we use the formula for 2 multiply with the depth of ground beam, and plus with 2 multiply with the base of the ground beam. Then, must not forget to less with the concrete cover. The concrete cover calculate for each side of the edge of girth inside the ground beam. Each edge, we have 1 horizontal side, and 1 vertical side. Now, a square will have 4 edge and multiply with 2 side. So, the amount of concrete cover is 8. As inside the British Standard, the size of a concrete cover is 25 mm. So now we multiply 8 to 25 mm in order to get the total amount of concrete cover that needed to be less in the calculation. After that, continue the calculation for the 10 mm diameter mild steel bar as strips. Then, proceed to calculate the total mass of 10 mm diameter mild steel bar as strips. First, we must sum up the total meter of 10 mm diameter steel bar used. Then, refer to BS 4449, Table 2 to find the mass per meter for 10 mm diameter mild steel bar. After that, the grand total multiply with the mass meter of 10 mm mild steel bar. Finally, we will get the total mass of it. Lastly, let us proceed to the last part of ground beam quantity measurement. The last part is about formwork. The description is sawn formwork. To the sides of ground beam, the calculation is to calculate the formwork used for ground beam. For the ground beam, the formwork only be used in both sides of ground beam. So we need to have the total amount of ground beam with the same size and multiply with length of ground beam. then multiply again with the depth of ground beam to get the total of formwork used. After that, proceed to continue the calculation of formwork. The step of calculation is as before described. Sum up the total and get the grand total of formwork used in ground beam. Then, this will be the end of the ground beam quantity measurement. Please remember to look back to the taking off list, check every part of the subtopic of the measurement that being calculated, and mark it with red pen. Now, here will be the animation of how the steel bar and steel fabric reinforcement were arranged and placed inside the ground floor slab. If the ground beam depth is larger than the depth of the ground floor slab, then there is no need the construction of formwork for ground floor slab. Now, let us look at the construction of ground floor slab. At here, this video shows an extension of ground floor slab. First, the ground beam were constructed at the end of the slab. Next, the steel bar for ground floor slab were placed and arranged. Then, pouring the ready-mix concrete into it. That is how the extension of ground floor slab be constructed. Second part of our quantity measurement is about ground floor slab. First, before we start the quantity measurement for ground floor slab, let us look toward the ground floor key plan, and also the ground floor slab detail plan. From the ground floor slab detail plan, we know that there are a few layers inside the ground floor slab. It stated the hardcore, the reinforced concrete, the steel fabric reinforcement, the reinforcement bar, and the damp-proof membrane DPM. So, as usual, we have to write down the title of the quantity measurement to state that. The second item that we are about to calculate is about the ground floor slab. As a reminder, must always don't forget to form the taking off list, include the query list. Then, when start to calculate for the ground floor slab, follow the sequence as what the subtopic that you are about to calculate, same as in the taking off list. So starting, we begin to calculate for the hardcore of ground floor slab. Remember, whenever we are going to start the calculation for each subtopic, must not forget to written down the title of the topic, and the description for each subtopic. For hardcore, we will write the description as hardcore filling 150 mm thick consisting of gravel reject, blinded with oxygen, to receive concrete including leveling and compacting of ground floor slab. Now we try to look back to the ground floor key plan to see the size of the slab. We will get the length of slab is 5000 mm less with 2 multiply with half of a brick wall. Then we will have the total length of 4775 mm. For the width is 5000 less with 2 multiply with half of a brick wall. So, we will also have the same amount as the length, where it is 4,775 mm. Now, let us proceed to the next subtopic, which is about the reinforced concrete and ground floor slab. As usual, must not forget to write the title on top, and also the subtopic description below the title. Now, find the length and the width of the slab, and multiply with the thickness of concrete, which is 175 mm. Next, let us proceed to the steel fabric reinforcement. The description of this subtopic is steel fabric reinforcement in ground floor slab. 2BS 4483, refer to A39 their mesh with 100 mm end and side lap. Look back to the ground floor slab detail plan. At here, we can see that the length of steel fabric reinforcement used in the ground floor slab. Now we start the calculation for the position at AP. For the first calculation, for the steel fabric reinforcement that located at AP as in the ground floor slab detail plan, we can see that the steel fabric reinforcement located at AP is at the end of the ground floor slab, where it is at the left corner of the ground floor slab. In a more precise drawing you can see is by looking at this picture. In this picture shows that how the steel fabric reinforcement were positioned in the ground floor slab. At first we calculate for the length of the steel fabric reinforcement. Then we can clearly see that there is only one bend at the end. So must remember to add a bend for one side only. Must also don't forget to less the concrete cover. The steel fabric reinforcement is always being placed after the concrete cover. So, the end there, the steel fabric reinforcement only touch one side. This means that we only need to less one concrete cover. Now, to calculate the actual length of steel fabric reinforcement located at AP, from the plan we will have the length, which is 1,700. Add half of a column stump. Then less one concrete cover, and add bend with a bend of 100 mm as described in the ground floor slab detail plan. Then, we will get the total amount of the length of steel fabric reinforcement. So, we now proceed to get the width of the steel fabric reinforcement. For the width from the ground floor key plan, we can see that the width is 5,000 mm. Now, we look back to the ground floor slab detail plan, and also the picture that we showed you just now. The picture shows that, in actual, the steel fabric reinforcement will have two bend at the end. One at the beginning of the steel fabric reinforcement, and one at the end. Look back to the quantity measurement. The calculation will be like this. We put in the width of 5,000 mm. and less to multiply with half of a column stump. Then, less with 2 concrete cover. After that, add 2 bend. After that we will eventually get the total width. Next it is the same for the following calculation of steel fabric reinforcement, but the size of it is depend on the drawing plan. For the last step of the steel fabric reinforcement, we have to calculate the mass of the total steel fabric reinforcement used. So we add up all the amount of steel fabric reinforcement used, and then time with the mass per meter square of the steel fabric reinforcement. The mass per meter square is attained by refer toward the British standard of BS 4483, reference A393. At the end, we will get the total mass of the steel fabric reinforcement used. Now, continue the steel fabric reinforcement for section B. The step of the calculation will be the same as the previous in section A. Now we move on to the next subtopic of the quantity measurement in ground floor slab. The next subtopic description is 10 mm diameter of high tensile bar to BS4483, as described in ground floor slab. Let's us to back to the ground floor slab detail plan to see the positioning and the size of steel bar place in the ground floor slab. Now we can start the calculation by the information obtained in the ground floor slab detail plan. Start the calculation by calculating the length of steel bar used in the ground floor slab. The length will be calculated by 500 mm length, add half of the column stump, and less one concrete cover. This is for the steel bar at the location of AP, so we now will have the total length of the steel bar. After that, proceed to the width. For the width of the placement of steel bar, is stated that the steel bar is being placed one by one of 200 mm from center to center. So, from the ground floor key plan, we can see that the width of the placement of steel bar will be according to the width of ground floor slab. Now, the width of the ground floor slab is 5000 mm, and less with two concrete cover to get the width of it. Then, in order to find the bill of steel bar, use the formula total width divided by the gap in between the steel bar, which is 200 mm center to center, and plus with 1. Then, we will get the total bar place in the slab at the location of AP. Now here will be the continuation of the calculation of 10 mm steel bar inside the ground floor slab. Refer back to the step as shown for the previous calculation. Lastly, after we have calculated all the amount of 10 mm steel bar in meter, we will then total up and proceed by refer back to the BS4449 table 2 to get the mass per kilogram of the bar according to the diameter of steel bar, so that we can multiply the amount together to get the mass of the total. Now let's move on to the last subtopic of the quantity measurement of ground floor slab. The last part is about the DPM, which is the damp-proof membrane. At here the description is polythene horizontal membrane. Not less than 100 gauge lap distance, 100 mm distance at joint, and laid hardcore. So now, start the calculation of DPM, where the length same as the ground floor slab, then less with 2 multiply with half of the brick wall size. So, we can get the total length for DPM. For the width, take the width of the ground floor slab, and also less with 2 multiply with half of the brick wall size. So, we can get the total width for DPM.
순간마다 네가 떠올라 조용히 나